It helps to know that when they say tangentially to the disk, what it really means is right at the edge of the disk. So the disk is spinning about the center. So force is applied right at the edge of the disk at the radius of that disk. Okay. So that helps to just know what that sort of what's that sort of conventional speak is. Okay. Let's go ahead and write down all the knowns. We have a disk of 0.15 meters. It has a force applied tangentially to it, 45 newtons. And because of that, disk is going to start rotating at a acceleration of 120 radians per second squared. And they want to know how much does the disk, what the mass of the disk is. Let's go ahead and look up how we're going to get the mass in terms of what we do know about rotational quantities. And first thing I'm thinking of is um, we probably want to do Newton's second law for rotation. They have alpha, and they have force, which can easily be put into torque by just multiplying force in the radius, especially if the force is put perpendicular onto the edge of the disk. What we don't have though is I, so we need to know what I is, especially for a solid cylindrical disk. So we look it up online and we see that I for a solid cylindrical disk is 1/2 mass of the disk times the radius of the disk squared. So now we should have all the tools we need in order to solve the problem. We got torque net is equal to I alpha. This is Newton's second law for rotation. Now let's get it into familiar terms. We don't have to put everything linear or everything rotational. We can make some things linear and some things rotational as long as the equation still works out. And so these two still have to equal each other. So since we have force, let's get torque into force. The equation for torque and force is F cross R, but we know that the F that's being applied to this disk is perpendicular to the radius vector here. So we could just say it's FR. And that's going to equal to I of the disk, which is 1/2 mr squared times alpha. And it looks like we have everything we need. We need m. We have r, we have alpha, we have r again, we have force. So this actually ends up being a really simple problem. Mass is then equal to 2 times force divided by r squared and alpha. I apologize, it's actually r times alpha. And the reason why is because one of the r's gets canceled out with the r on the left. So it becomes actually over r alpha. Plugging in all of our knowns, F being 45 newtons, alpha being 120 radians per second squared, and R being 0.15 meters, we get M equaling to 5 kilograms, but we know that we have two significant figures as our least amount of significant figures as given. So we'll say 5.0 kilograms. And that's the answer. The mass of the disk, in order for this condition to be met under these premises, is 5 kilograms.